Hi guys, this is Shivam. I'm your engineering advisor, and today I'm going to cover the webinar on engineering. It's a very abstract, like the idea of in the webinar is pretty abstract. It's why engineering, but we'll talk about the different means that you could possibly explore while you're in your engineering on your engineering journey, and at the same time, what kind of like career prospects, and further studies or well if you want to like amalgamate different engineering domains, that's also like something that we're going to cover in this webinar. So let's get started. So talking about like what engineering offers, it offers you the chance to like go for like limitless creativity. I mean, you look at like the thinkers, entrepreneurs, or I don't know, like CEOs or CTOs, they have a lot of them have like an engineering background. And what does like this engineering background offer them is, the chance to like go above, go from their respective experience and knowledge and try to amalgamate it with something else, something that they have heard of, something they have got the chance to work with or something. So that's how you can go from point A to point B, not in just like a single line, but like in multiple ways. So it's one of the important like factors that engineering offers, and one of the major advantages as well. Innovation is something that comes hand in hand. As engineers, you're supposed to innovate to come up with new product ideas. You design new products, or you work on the existing products and try to make it better. And problem solving mastery again, because you will be given like hands-on experience whether it's like in terms of equipments, or in terms of projects that you might do on your uh, computer or something, or you run some kind of like simulation, or you run some softwares that help you solve problems. So with engineering, you kind of like develop this kind of like a problem solving mastery as well. And at the end of the day, this is the most important. That is, you try to like have a name in the world, like have your own name in the world, because it offers global impact. You have the opportunity to make your name heard in the global market, or just for like example, like let me talk about uh, Elon Musk. I mean, Elon Musk has an engineering degree. He has various startups, and if you look at like his journey, he's he's always made an impact. Whatever he's done, whether it's like Tesla, SpaceX, and just to name a few. I'm pretty sure he has like other startups as well, but these are the two most popular. So as an engineer, you get the opportunity to make a global impact, which is, I think, pretty cool for me. Talking about the majors, let's look at like the majors. So we have mechanical engineering, where you basically deal with finite element analysis, and you work with engines mostly, and you get like you this is like one of the fields where you get the most hands-on, because you get to work in labs, and you see how equipment works, and how you see how the software is controlling the equipment. So you see how software relates to hardware, and how hardware can also relate to software. So it's like intertwined. Electrical engineering focuses more on the hardware part of things. So you have like electrical equipment, like let's say you have like a uh, you have like a you have like a breadboard. Okay, so you want to like tune in the hardware. You have like some kind of like wires, or some kind of like LED lights or something. You want to tune in, and you want to calculate the wattage, or like uh the amperage, or like the voltage for that particular like breadboard. And then when you calculate that, you want to make changes to the way the wires are connected, or something that will in turn like change the way the output is generated in the software. So Electrical engineering is another major that people are like really focusing on. The people like really focus on. Civil engineering is also, I would say, like a hands-on experience. You get to have like an experience. How different like structures are made, and what quality of materials are like used to build that structure, and considering the situation where there's like a environmental hazard, or there's like a storm or some kind of like natural hazard. So how you could like make structures in a way that will resonate to the damage, and that won't impact anyhow. Besides like building structures, you have like another important application of civil engineering, and that I think is like really crucial, is building like water dam projects. Like a lot of water dam projects requires a skill set of like efficient civil engineers, because they need to be constructed like at uh, a particular angle, so that when the water falls, the right amount of electricity is generated, and the hydroelectricity principle is followed. Chemical engineering, computer engineering, and aerospace engineering. Chemical engineering is like a combination of chemistry and like using chemistry in the engineering space. So as I talked about, that engineering offers limitless creativity. I think chemical engineering is like one of the most, if not the most, unique engineering domain that is out there, like currently. And you get to like work with chemicals, but at the same time you see how these chemicals are used in the synthesis of different like products, or like the different kinds of, like, let's say if you go to like if you do like a factory visit, you get to see like uh how the like if there's an equipment, how oiling is done properly, so that there's no kind of like wreckage, or there's no kind of like friction between the equipments, and the equipments are like able to run efficiently. So chemical engineering is another like engineering major, and for me possibly the most unique engineering major out there. You get the uh you get the like you get to learn about chemistry, and at the same time you get the opportunity to apply chemistry to different like engineering principles, or engineering design, or engineering softwares. Computer engineering I think computer engineering lies within the intersection of electrical engineering, computer science, and computing, from what that I mean. And computer engineering is like really in demand as of now. And computer engineering like focuses more on hardware, but mostly I've seen that computer engineers, like the computer engineers that I know personally, and from what I've heard, is that they have good experience with the software as well. So they know how to code, they know how to like run different softwares, they know different kind of like programming languages, because they have to like make the computer work, and they have to make the hardware work. And for that, in order to like make the hardware work, you have to like have a good understanding of the software in the first place. So computer engineering is another major that is out there. Aerospace engineering is for me the most exciting engineering domain, personally, because as I talked about Tesla before, you get to like work. So I talked about SpaceX before. So you get the opportunity to work for like SpaceX and NASA, that they're like really into like building rockets, or they they're like really into designing like fuel supply methods that propel the rocket. So it's another like really cool, interesting domain that people should, I think, really explore. And this is like one of the quotes that I live by, and is like really close to my heart. And it's by like one of my most favorite like entrepreneurs as well. It's like from Elon Musk, and he says that engineering is the closest thing to magic that exists in the world. And I can't agree less, because I kind of like get the vibe that as engineers you're supposed to be like meticulous, and you're supposed to do your like 9 to 5 job, and you really don't get the opportunity to innovate. But the thing is that as much as like time and energy you devote to like an engineering domain, let's say a computer engineering, you get to learn like how the how the domain actually works, or how, computer, what is actually computer engineering. I mean, we can just like go to Google and, search what is computer engineering, and we can come up with an abstract definition that, we can possibly like mug up and stick to it for the rest of our lives. But when it comes to application, I think with engineering is that, you need to give it time. You need to give engineering time. You need to take in the time to, absorb all the content, let her like mind evaluate it, and then, it's just gonna go straight like upwards for you, because you will possibly like come up with something. You'll try to like solve some kind of problem that already exists, and from your like existing engineering knowledge, you can possibly, work on that, or, design a solution for that. So that's why I think like engineering is the closest thing to magic that exists in the world. So talking about the some kind of like engineering innovations that have kind of like changed the world, we have the rocket here, obviously one of the most important like man-made discovery, engineering discovery, and we all know that, how what rockets do, and how they're important to like human survival. Then we have the World Wide Web. He's like introduced by Tim Berners-Lee. He's introduced in 1999, and this was the advent. This actually led to the invent of the like internet, and yeah, I'm pretty sure that we would have like uh, a very different life if not for the WWW. So it's another one, like one of the most miraculous engineering innovation that I would say. Another is like this, like the telescope. This telescope, helps us see galaxies that are like way apart, and we actually are able to see how our like solar system actually works, or what's beyond the Earth, and we are just like some tiny specks in a like large galaxy of dust, and it really has helped like scientists as well to know about different like like different resources, and is like life possible outside Earth and everything. So they are like with the help of like with the help of discovery of an invention like telescope, scientists are like getting their scientists are getting like a lot of their questions answered. And then we have the computer. I mean, like I think again the impossible without the computer. Like if they were like not computers, then I don't think they would have cell phones. If they were no cell phones, we wouldn't have Instagram. If we didn't have Instagram, we probably wouldn't have Snapchat. So you see the correlation. And then again, like one of the another like major inventions that you really like is the bullet train. Connectivity is for the first train, or the train in general. Train helped in connectivity. Bullet train helped in faster connectivity, and by faster I mean like super fast connectivity. So yeah, I mean I can go on about this for like hours and hours, but giving you the gist of it, they are like like I can't count. They're like unimaginable number of engineering innovations that have come into picture and have really impacted human lives. And some engineers who have like and who are like kind of like changing the world. We have Elon Musk, we have Nikola Tesla, we have the Nvidia CEO who's Yuan Zhang, and then we have Thomas Alva Edison who invented the light bulb. So what do you get to do as an engineer? So as an engineer, you get an opportunity to make an impact. Uh, Probably I covered this before, but I want to emphasize on the fact that how the definition of the word engineer came from. So the word engineer came from the Latin word ingenium, which like literally translates to like being like a problem solver. So as an engineer, if you're an engineer, or if like you're pursuing an engineering degree and you need some kind of like motivation, you should be proud of yourself. You should just think that, hey, I'm like a problem solver. I took this degree. I know it's challenging for me, but at the same time, I'm I'm one step closer to being like a problem solver, because there's no like, I would say, defined criteria for being a problem solver. I mean, we can be like problem solvers for like sorting out the slightest inconvenience, but as an engineer in that context, it's different. So here's how like I would like want you to think as though like how you could like possibly undertake an engineering degree or domain. So, think of the like major environmental challenges like climate change or the kind of like, problems that are faced in the healthcare sector. So, if you want to make an impact in the environment, there's a possibility for you to become like an environmental engineer. If you want to make an impact in the healthcare sector, then, you can probably pursue bioengineering or nano engineering and, work on solutions there. But the gist of it is that, as we as we move forward, as these like new innovations come up, the problems that exist also increases. So there's like a direct correlation. So as the humans progress, so the problems also. So as the problems also progress, so there will be never a demand for engineers in this world. And when I say never, it actually translates to never. So wherever problems exist, we need engineers and we should have engineers. And I touched on this point before that, as an engineer, you have the flexibility to innovate as you want. So, I mean, you might like start like with a chemical engineering degree, but you work on something or you come across something that requires or that makes you like more passionate towards civil engineering. That's fine because the engineering principles, uh, the core, the core values, they remain the same. The implementation might be different, but the core values they remain the same. Different careers in engineering is like this is like a hierarchical chart. So at the top, we possibly have like computing and computer engineering. Then we have mechanical and electrical on a common ground, almost at the same. And then, as we go down, you can think of this like the popularity choice. So you see like most number of computing or like computer engineer professionals, then you see mechanical engineer and electrical engineers almost on the level ground. And then below that, you can see chemical, aerospace, industrial, and civil engineering. That doesn't mean that, these domains, like the ones at the bottom, they're like not really in demand or like they're not high paying jobs. It depends from person to person and their interests. Right now, we live in a world where, you know, everything is about AI and everything is about like computing and, solving problems. So who knows, like, what's the next revolution gonna be? It might be something related to chemical, something like related to rocket fuel or something. So I would say that, there's no, uh, there's no, it all depends on your passion. I think firstly it comes to your passion, and second of all, I mean, if you really want to do it, so if you're not really into coding, if you don't like really want to know how computers work or how different programming languages work, then there's like no actual need for you to like do computing just for the sake of the job, because in the long run, if you see, you won't be actually happy doing it. Or if you're like interested in how rockets are designed, or how rocket fuel is, uh how do you calculate the rocket fuel requirements for like a spacecraft or like a rocket, then you should possibly like pursue aerospace engineering. So I think your passion and your willingness to commit and be persistent about it, that's what really matters. Is that all? Of course not. Yeah, like obviously, like as I talked about limitless creativity and unique and being flexible, right? So there are like various other like subdomains and sub interdisciplinary engineering domains that you can possibly pursue. So I was talking about like bioengineering. So bioengineering professionals, they have like some kind of like knowledge about biology, that is like health, and some hands-on with engineering as well. So bioengineering, like we have it as like an amalgamation of biology and like engineering. We have something called mechatronics as well, which is like uh, a kind of like a correlation between mechanical and electrical engineering, mechanical and electronics engineering. Something like we have called automobile engineering. That is like, I think, uh, a subpart of aerospace engineering, but automobile engineering like really like almost like focuses on car designs and stuff like that. So at the end of the day, it's totally up to you. And if you're like going to like a college or university, you should actually read through their programs and see what kind of like programs are they offering. Do they like relate to your interests? I mean, if you are really into cars and you want to get to know about car designs, what are they offering automobile engineering? Okay, if they're not offering automobile engineering, what is the next best thing to automobile engineering that they are offering? So that's how like you approach your like career prospects. Let's say that you decide to work, you're done with your engineering degree, and you decide to like I think I've learned enough, and now I want to work. While you're like applying for jobs, it really is important that you apply to jobs that you actually want to work for. I mean, let's say that I'm a computing professional, but I applied to a job which is like into uh chemical synthesis. Am I gonna be good at that job? Might be. I don't know. I might like learn a lot of things. I might like learn new things. But here's how you have to like approach the situation. You, as I talked about, you being flexible and you being passionate about it. These are the two important like things that I think anyone who wants to like make a career out of engineering has to look forward to. And obviously being persistent about it, that because engineering requires commitment. You can't like be that 3 months of focus won't like make you all passionate or something. So you require commitment, you require flexibility, and you require passion. And talking about the most interesting part, how well do these jobs pay? So engineering jobs in general, I think they pay pretty good. Uh, Petroleum engineering, again, as I talked about, the different interdisciplinary fields that engineering offers. Petroleum engineering is another. It's between chemical and industrial engineering, but at the same time, these jobs, they're based on like median pay, and it depends from uh company to company, location to location, and your experience level also matters. So talking about petroleum engineering, I mean, pay might be great, but the opportunities might be limited. But if you talk about chemical engineering or electrical engineering, computer science or computer engineering, the average might be like low on this graph, but at the same time, the number of jobs there are actually very high. So you should think it in this way that uh, the lower the graph values, the more number of jobs they have, because that kind of like saturates the market for the jobs, and that kind of like saturates the median pay. And petroleum engineering, actuarial math, nuclear engineering for that matter, they are like excellent jobs and they like require top commitment. But at the same time, they're like not really plentiful. So that's where it really boils down that, what kind of program you want to pursue and what kind of like engineering degree or domain you want to pursue. Do you actually like want to work after you graduate, or if you have like a business or something that you want to like try it on, or you want to continue like learning more about the program, or you want to like pursue high studies, like you want to do a PhD. So it all like depends on you, I would say. Talking about the number of engineers in the world, there are quite a few. There are like 12 million engineers in the world. To be honest, I think that number is kind of like low. I mean, I expected it to be kind of like more on the high, but 12 million engineers doesn't sound that bad, does it? Yeah. Let's just think that, you will be joining, like if you decide to pursue engineering, you'll be joining these 12 million like problem solvers, and together you would try to make this world a better place, this earth a better place. And the kind of problems that we are facing, we all know about that, whether it's like environmental, whether it's in healthcare, whether it's in fraud detection or anomaly detection. We all know that uh, as our like lives become more complex, the problems also increases. So we need this number to grow up exponentially, I would say. So there's never like a shortage of engineers, and I hope you guys like make up to these numbers. I mean, like I'm one of them. I hope that one day you guys also come up to this number. Really looking forward to that. Uh, So now like I want to do like a comparison of like median annual salaries between engineering and like like other occupations, something that is like non-STEM. Possibly it can be something in finance, something in marketing, something in arts, something in literature. And you can see that engineering occupations right here, they beat the other occupations by quite a margin, I would say. Yeah, it's quite a margin. And again, I said that, this engineering occupations, they cover uh everything, like they cover like all the engineering domains and the possible job opportunities that come with it. Engineering tech occupations are something that is like middle ground between computing and engineering. Computing occupations is solely focused on computing occupations. We all know that the number of like the opportunities for computing occupations is always on the rise. And if you look at this like graph, this kind of like shows us that it's actually on the high. It's rising. And if you compare it with like with other all US occupations, you could see like a considerable difference. And that's what the point is. I mean, like because as an engineer, you're gonna be like a problem solver, and you know to be an engineer, it's not like an easy task. I mean, you can't like decide one day that hey, I want to be an engineer, and yeah, let's do this. You require commitment, you require like passion, and you have to stick around. That's the most important aspect. And if you make it through, and people are gonna see it, the recruiters, they're gonna see it, the companies where you apply for, they'll see, this person has like worked, or they have had like an engineering degree. So I mean, they have it in them. So they're gonna pay you for that. They're gonna pay you for all the stress you took, all the sleepless nights that you had while you were trying to get this degree, because they know that you're committed to the cause, you are committed to the major that you were like probably pursuing in your engineering degree, and they are paying you to be problem solvers. You should look at it from that point of view. And I'll now talk about, the popular engineering schools that we have. So we have obviously UC San Diego. The Jacob School of Engineering is one of the best schools of engineering I would say in the US. And we have like programs stretching from, electrical to petroleum to like aerospace engineering. And we also offer like the Jacob School of Engineering also offers you to like if you want to switch from one engineering domain to another if you want. And there's a possibility of you for you to like pursue like a dual major as well, but there are like certain kind of requirements that you'll have to meet for that. But again, it's like UC San Diego is like one of the best places to pursue your engineering. And uh, I'll say like Mm, that's because not only of the curriculum, but at the same time, the kind of like extra opportunities that also come, like the research opportunities, or the kind of like the industry collaborations, or uh lab work or something like that. So that's gonna just like make you, I'd say, a better engineer. Then we obviously have like the Harvard University, Caltech, Berkeley, UCLA. These are all one of the best, if not in, I would say they're like one of the best engineering schools in the world. And they offer you the flexibility. They have a curriculum that is like very academically very rigorous, but at the same time, when you're done with it, you're like, hey, I know everything. I know everything about my major, or like your possible uh like thesis or something like that. So they are going to like they'll try to take the life out of you, but at the same time, once you will done, you will just like really appreciate your time there and your experience there, your networking there, and the opportunities that came along. And thank you. That's it from my end. You guys can like always reach out to me in case like you want to like talk about engineering in general, or you want to explore like further different like engineering majors. I just like gave a gist of the the engineering majors that mostly people choose, but again, they're like some kind of majors that is like not that they're like super unique and that not everyone actually pursues them. So I would really appreciate that, if you guys could like give me some kind of feedback on that. And we we look forward to seeing you in like I look forward to seeing you in the group advising session. I would like really love to like solve your queries and help you out with your career path. Thank you so much.